So this is the case of dissociation. Let's understand the case of association. If you are having a n number of solute particles and after the association it will become an. Okay, so that n number of solute particle will get associated. All right, so let us consider, firstly you are having 1 moles of solute particles and before the association you will get a 0. After some time, if alpha particles are dissociated from 1 mole, now what you will get? Alpha by n particle, because that alpha particle will be associated, not dissociated. So in the case of association, that n number of alpha particles are there and that n number of alpha particles are now associated. So we will write it like alpha by n. Now how you can find the value of I? So I is equal to number of particles after upon before. So after you will have 1 minus alpha plus alpha by n, and before you are having 1. So from this solution, if we take the alpha as a common, I is equal to 1 plus alpha, that will be, or minus 1 minus 1 by n. So you will get, this will become I minus 1. So you will get alpha is equal to I minus 1 upon, or 1 minus I, sorry, this will be 1 minus I upon 1 minus 1 by n. So this will be the relation between alpha and I in the case of association. Okay. Okay, one more topic is there, what we have left, that is the type of solutions, type of solution, type of solution on the basis of osmotic pressure, on the basis of, on the basis of osmotic pressure, osmotic pressure. The first one is isotonic solution. What is isotonic solutions? Isotonic solution. So the solutions having same osmotic pressure are called isotonic solutions. Solutions having same osmotic pressure. And that is possible when solutions having the same concentrations. Solutions having same osmotic pressure. Osmotic pressure are called isotonic solutions. Okay. Pi 1 will be equal to pi 2. Okay, how? If we take the example of in our body, so our cells containing the liquid, our blood cells also, like blood cells containing liquid, containing liquid inside. If we put that cell, if we put that cell in 0.9% sodium chloride solution, then it will form a isotonic solutions, means there will be no osmosis. The movement of solvent will not take place. It will form, it will form isotonic solution. Isotonic, isotonic solution. Okay, so the second type is hypertonic. Hypertonic. Hypertonic solution is that solution which is having more osmotic pressure than the normal. The solution having more osmotic pressure than the other solution, so that solution is called hypertonic. The solution having more osmotic pressure than the other solution, that is called hypertonic solution. Okay, again here for this also we can take the example. If we put the cell in more than 0.9% NaCl solution, है ना, we put cell in more than 0.9% solution, NaCl solution. So the cell will shrink because the liquid inside the cell will move out toward the NaCl solution. So there the osmosis will take place and the solute molecules will move toward the NaCl solution. So the cell will shrink. And the third type of solution is hypotonic. Hypotonic solution is that solution of which the osmotic pressure is lower than the other solution. Here pi 1 is greater than pi 2 and here pi 1 is less than pi 2. That is the osmotic pressure of given solution will be lesser than the osmotic pressure of other solution. Again we can take the example. If we put that cell in a solution lower than 0.9% of NaCl, so the cell will swell. That is, the solvent molecule from NaCl solution will move toward the cell and the cell will swell. Okay, so these are the three types of solutions on the basis of osmotic pressure. So after this topic our solution chapter is completed. Now you can do the practice questions or exercise questions. Okay, thank you.